Welcome everybody to your 2.1 video lesson. Today we're talking about different methods for graphing. So we're going to do 3 different things today. We're going to graph from a table of values, from slope-intercept form, and from x and y intercepts. Now before we get into that, we just want to do a quick application problem using slope. Okay, so we know that our slope formula y2 minus y1 over x2 minus x1. Okay, so we want to find this missing value of r. It's one of our coordinates for our ordered pairs for a line passing through 2, 3, and 6, comma r, and it has a slope of 1/2. So it's kind of working backwards. So instead of solving for the slope, we're solving for part of the ordered pair. So if I have an ordered pair, I can always label that x1, y1, x2, y2, and then I can plug that in to my formula here. So in place of y2 and y1, okay, I can plug in the coordinates that I'm given. So I have r, which is fine. It's a variable. I'm going to plug it in. Okay, now I can't solve an equation that has 2 different variables, but I happen to know the slope. My slope is m, and that was given to me in the problem. That is 1/2. So I can also plug in my slope here. Okay, I can simplify 6 minus 2. Okay, and now I have a proportion. I'm going to solve this like an equation. Okay, we solve a proportion using cross multiplication. So 4 times 1 and 2 times r minus 3. We want to make sure that we use parentheses so that we distribute to the entire expression. Okay, we're just solving our equation now. And we find that our missing coordinate is 5. Okay, so just a quick little application of slope. We plug everything in that we're given in the problem to our slope formula. All right, so now that we have that, we can begin our methods for graphing. So the first thing that we're going to look at is a table of values. Okay, so when you're creating a table of values, you're going to create 3 columns. Okay, an x, a middle space for work, and then a y column. And we're always going to use the same x values, -2, -1, 0, 1, and 2. Okay, you plug all of those in, and then you set them into your equation. Now, you may want to solve your equation for y before you begin to make it a little bit easier to solve. Okay, but once you do that, you're going to have 5 ordered pairs. So let's see what this actually looks like. Okay, so it says use a table of values. So I'm going to set up my 3 columns here. Okay, and this middle space is going to be for work. Now, I'm looking at my equation, and I definitely am going to want to solve this for y before I start. So back in Unit 1, when we did literal equations, okay, we talked about how we're going to hear solve for y, solve for y. This is the reason. Slope-intercept form and graphing. Okay, we want to isolate this. So remember, we move the x and then we divide. So my equation is y equals -2x plus 3. So -2x plus 3 is what I'm going to put in the middle here. Okay, so my x values, we said those are always the same. And now we're going to plug them into our equation. Okay, I've also seen we make a extra column over here, and you can rewrite with your ordered pair. It just makes it a little bit easier to look at when you go to plot your points. Okay, so this last column here, this is totally optional. Okay, it's kind of just an organizational tool for you. All right, so now we're just going to plot our points. Okay, so -2, 7, -1, 5, 0, 3, 1, 1, and 2, -1. Okay, so for a table of values, you always need to have 5 points. Okay, if those are the directions for the graph, you want to make sure that there are 5 points on your line. Okay, use a straight edge to connect. You want to make sure that you have arrows on the end, okay, because your line does continue. Okay, so that's it for table of values. I think you've probably seen this before. Okay, so this is just a nice little refresher for you. Okay, our second method, and this is probably going to be the most popular that we're going to use throughout the year. This is slope-intercept form. Okay, so slope-intercept form is y equals mx plus b. Okay, m is your slope, and b is your y-intercept. Okay, so you're going to begin at the b value. You're going to begin your graph at the b value. That goes on the y-axis. And then you are going to move with your slope. Okay, you're going to do rise over run from your y-intercept. You're going to make at least 3 points on your graph. You may want to make more though. Okay, so you first want to make sure, is your equation solved for y? Is it in y equals mx plus b? And this one is. Okay, and then you're going to label your m and your b. All right, so my b is -2. So on the y-axis, we're going to mark -2. That's where we begin. From that point, we're going to move with our slope. Okay, my slope is -5/2. This is my rise over run. So if it is a negative rise, we're going to go down. And if it's a positive run, we're going to go to the right. Okay, an equivalent for down and to the right is up and to the left. Okay, those will get you in the same place, because sometimes maybe you run out of graph in one direction and you got to go back the other way. Okay, so we're going to go down 5 and to the right 2. Okay, and this is a situation where if I tried to make a third point, I would run out of graph. So I'm going to go back to my y-intercept at -2, and I'm instead going to go up 5 and to the left 2. Okay, and you see how that point falls in line with the other two that I already had. Okay, you can create another point if you like. 3 is enough for me though. And then using your straight edge, you're going to connect. Oh, pretend I hit that last one. Okay, you're going to connect your points. Okay, and that is your line using slope-intercept form. Okay, let's look at another example of this. The slope-intercept form is very, very important. Okay, so what is the first thing that you notice about this example? Pause your video, think about it for a second. Okay, hopefully you have said that this is not in slope-intercept form. This is not solved for y. Okay, and in order to solve or I'm sorry, in order to graph in slope-intercept form, it has to first be solved for y. Okay, so at this point, we should be very, very skilled at solving for y. Okay, we know to move the x and divide. Okay, so I'm going to identify my m and my b. Now my slope here, I don't really have a rise over run, it's just a whole number. So while I'm here, I'm going to make this a rise over run by doing -5 over 1. Okay, so I'm going to begin at my b, 7 on the y-axis. And then I'm going to move with my slope. So this is down and to the right. So down 5 and to the right 1. Down 5 and to the right 1. Okay, I have enough points here. Use your straight edge, okay, and connect with arrows on the end. Okay, so this was another example of slope-intercept form, but this time we had to solve for y before we began. Okay, still slope-intercept form, but look at this equation and tell me what is different in this one. Okay, hopefully you realized there was no b value. This is just y equals mx. Well, if I have no b, how am I supposed to know where to begin? Okay, so if no b value is given, we assume the b value is 0. And I want you to put in a +0 when you write your equation. Okay, and at the same time, I just made my rise over run. I did 3 over 1. Okay, so I'm going to begin at 0 on the y, which is my origin. And my rise over run has me going up and to the right. So I'm going to go up 3 and to the right 1. Up 3 and to the right 1. Okay. And connect. Okay, so this is probably my favorite method for graphing. You are going to be responsible for all 3. Okay, so you will have to read the directions on any given problem to know what method to choose. And then sometimes you'll be given the option for method of your choice. Okay, while we're still in slope-intercept form, we have 2 special cases. All right, so this first one, it's just y equals a number. Okay, so there's not a full y equals mx plus b here. Okay, so when it's just y equals a number, I can find that value on the y-axis. So here's -2, because this is technically my b value. That is my y-intercept. That's where I begin. But now I have no slope. So the previous example had no y-intercept. This one now has no slope. So we're looking at y equals 0x minus 2. So a 0 slope. Okay. And a trick here to remember a 0 slope. Okay, anytime that we have an equation that is y equals a number and there's a 0 slope, this is going to be a horizontal line. Okay, so I need to put a line through that y value of -2, and I cannot touch any other y values. So the only way to touch that one y value is to go horizontally with it, okay? And if you look at the word 0 here, okay, the top and the bottom are horizontal lines. Just a little trick to help you remember. Okay? Now, the opposite case to that is when you have x equals a number. Okay, so x equals a number. This is not really slope-intercept form, because slope-intercept form is y equals. Okay, but we can graph equations like this, x equals a number. Okay, this is going to be the opposite. So we're going to find x equals, we're going to find 5 on the x-axis. Okay, and there's 5 on the x-axis. And the same thinking as last time, how do I get a line through only the x value of 5? So I don't want to touch any other x values except for 5. The only way to do that would be with a vertical line. Okay, so a vertical line actually has an undefined slope. Okay, and the undefined, we remember this, the u, is my little trick, the u makes a vertical line. Okay, so y equals is horizontal, and x equals is vertical. This is just something that we memorize. Okay, these are our 2 special cases. We can't really use a specific method to graph them. All right, so far we have hit table of values, slope-intercept form, and now we have these 2 special cases. All right, the last thing we want to talk about are x and y intercepts. So an x-intercept is where the graph hits the x-axis. So I can draw us a little sketch over here. Okay, so blue is going to be my line. All right, so this guy right here, that's my x-intercept. Okay, that's where I cross the x-axis. And the y-intercept, okay, we already know from slope-intercept form, that's where I cross the y-axis. Okay, now, the x and y intercepts are ordered pairs. This is very important. Write this down. Okay, and we're going to put a bunch of stars around this. Okay, x and y intercepts are ordered pairs. They take on a very specific form. Okay, they are a number, comma, 0, and 0, comma, a number, okay, respectively. So this is your x-intercept. Sorry, it's a little squished here. And this is your y-intercept. So if the x-intercept always has a y value of 0, and vice versa, the y-intercept always has an x value of 0, we can use that to our advantage in order to solve for these ordered pairs on our graph. Okay, so let's take a look at an example to see what I'm talking about. Okay, so this is telling me I'm going to plug 0 in for x and y values into the equation because that's where x and y intercepts occur. Okay, remember they are always stated as ordered pairs. If we do not state them as ordered pairs, then they do not count as x and y intercepts. Very, very important. All right, so let's do a graph like this. Okay, so here's my equation. So in order to find the x-intercept, all right, we know the x-intercept is going to be a number, comma, 0. Okay, because it's on the x-axis, the y values there always equal 0. We're going to use that fact to our advantage. So that means we can replace y in our equation with 0 because we know that's what it's going to be when we're on the x-axis. Well, if I put a 0 in there, that's essentially canceling this out. And now I only have one variable left in my equation. And I can solve. So I get x equals 6. But remember, the x-intercept is an ordered pair. So it is 6, 0. We're going to do the same thing for the y-intercept. Okay, but this time, it's always 0, a number. Okay, so think about it. If you are anywhere on the y-axis and you put a point, what's the x value at that ordered pair? It should always be a 0. So we're going to plug that into our equation. We know it's always going to be a 0 on the y-intercept. When I do that, now it lets me cancel out that portion, and now I can solve for y. And I get y equals 10, but it's an ordered pair. It's 0, -10. Okay, remember, x and y intercepts, that's plural, which means it should be ordered pairs, plural. You are not putting these together. Because if you just plot one point on your graph, how do you make a line out of that? You need at least 2 points. So 6, 0 should be on the x-axis as an x-intercept, and -10 on the y I'm going to be down here at the bottom. Okay. I'm not going to see it down here, but I'm going to connect. Okay, and I have my line. So really important to remember, x and y intercepts are 2 ordered pairs. Okay, they are 2 separate ordered pairs. So please do not put 6, -10 together. Okay, if you put 6, -10, that's only 1 point. You tried to put that on the graph. Again, you cannot create a line out of that. Okay, so these were your 3 methods for graphing. I definitely think that x and y intercepts is the most difficult one. Okay, so I encourage you to go back and re-watch the x and y intercept example. Okay, make sure that all of your notes are completed before you come to class, and you want to write down any questions that you have so we can go over those.